Okay, so what you're going to do now is an investigation of transformations of exponential functions. And what we're going to do is change a few things. Okay, so we're going to put this thing called a b value out the front. So remember, what we've been looking at is y equals a to the x. We're going to slap a b value out the front, and we're going to put this c value on there as well, and see what changing or varying these values does. Now, I'll just show you what we're doing by transformations. So what I'm going to do is pull up GeoGebra in a sec, and I'm going to say that we've got a function y equals 2 to the power of x, and what I'm going to do is have a b value in front of that and a c value. Okay, and when I do this in GeoGebra, what GeoGebra does is it knows that these things here are what we call parameters, and varying these things changes the overall shape of the graph. So if I just enlarge this, we'll see it a little bit better. So by varying this b value, what I can do is change the way the function behaves. And this c value, you'll notice here, drops the function up or down, or translates the function vertically. So by actually varying these values here, what we can do is try to get a model for what the particular behavior that we're looking at. Okay. So that's what we're looking at here, is what effect on the graph does changing, or has the change in the b and the c have on the resulting function. So there's going to be a fair bit of calc work here, and what I'm going to get you to do is just to stop and play this, or pause it and play it at various points. Okay, so what we're going to do is keep the base constant at a equals 2. So we're going to use the same base, a equals 2, and investigate that. So we've already done 2 to the x and negative 2 to the x. So what I'm going to get you to do now is to fill in the table of values and draw the graphs. Okay, so I've just unpaused the video now, and hopefully the results of your work look as follows. So I've completed the table of values for 2 to the x and negative 2 to the x, and I've noted the following things. So I've got a y-intercept of 0, 1, and a y-intercept of 0, negative 1. The equation of the asymptote for both of these functions, which I forgot to draw here, is y equals 0. Make sure you draw that with a ruler. And this one here was y equals 2 to the x, and this one here was y equals negative 2 to the x. Okay, so what transformation? So what we're going to say is this is a transformation. It's actually a reflection, okay? And the reflection, so with transformations, there's 3 types of transformations. There's a translation, a reflection, and a dilation. So this one here is a reflection in the x-axis. Okay, so here's the x-axis here, and the function 2 to the x gets reflected in the x-axis. And so this is a reflection in the x-axis. And note, the one thing that we want to really note is reflections in the x-axis change the y value, or negate the y value. So can we please note that down as well? We're going to say that reflections in the x-axis negate the y value, and the x value stays the same. All right, so part 2 looks at this b value here. Okay, so what we're going to do is start to vary the b value. So for this one here, the b value is simply 1. So we change it to 3, 4, 0.5. So again, what I'm going to get you to do now is fill in the table and draw up your graphs, and we're going to make your conclusions. So pause the video now and do that part, please. Okay, so resuming this video here, hopefully your table of values looks like that. So check that out. And your graphs certainly look a lot better than mine, I hope. Okay, mine have been really wobbly again. Please excuse my attempt at a smooth exponential function. Mine are all wobbly, but again, these are really difficult to draw with the equipment that I've got. Okay, so hopefully you see what actually happens with this b value here, so what it does to the values. So if we take the 2 to the x function and notice what happens here, it basically takes all of these values here and multiplies them by 3 in this case, so 2 times 3, 4 times 3, etc., etc., etc. So what we're going to do is make a conclusion. What transformation has occurred to 2 to the x with these changes? What this is, this can be named. The transformation is called a dilation, and we're going to say that's a factor of b from the x-axis. So what it does basically, it takes that original function there and multiplies it by this dilation factor, and we go from the x-axis. This one goes to the x-axis or gets closer to the x-axis, but we can still use that terminology of from the x-axis. We're going to make one more conclusion about this, is notice that for each of the functions, these x values remain consistent, and what changes is the y values. Okay, and so what we're going to say is dilations change the y values by a factor of b, but the x values remain the same. Okay, so that's the dilation factor. Okay, and in the previous example, we did reflections, and these are the transformations. So the next thing I think we're going to do or look at is translations. And that's exactly what we've got. So this c value here, what it will do is it'll move the function up or down by whatever the value of c is. Okay, so what I'm going to get you to do again is to fill in the table of values using these values here and draw your graphs. Okay, so pause the video and then have a look at my results after you've completed yours. Okay, so I'm unpaused now, and again, what I want you to do is have a look at your table of values. And the one thing I'm not too sure whether you would have got or picked up is the effect on the asymptote. Okay, so what you may notice is that this +3 and this take 5, what it does is it basically takes all of these y values here, and in this case adds 3 to the y values. Okay, so if I shift up all of the y values by 3, what also happens is I grab this asymptote here. That's a mistake, that should be y equals 0. But I grab this asymptote here, and what I'm going to do is move it up, in this case, by 3. So my asymptote becomes y equals 3, and in this case here, moves it down -5. So your graph should look as follows, with 3 asymptotes, or 3 different asymptotes, one at -5 for this function, one at 0 for the original function, and one at 3 for y equals 2 to the x plus 3. Okay, so this one here is y equals 2 to the x plus 3, because I can see here that the asymptote has been moved up by 3 units along with basically every point by 3 units. And this one here, or this one here is y equals 2 to the x, and this function here was y equals 2 to the x take 5. And what's happened is all of these values here have been lowered by 5, including the asymptote. So the asymptote has been shifted down 5 units. So what transformation has occurred to the function with these values of c? A translation is what we call this. We're going to say c units vertically. So c units up or down, okay? And translations vertically, in this case, change the y value. So it's important to note that these particular transformations, the translations vertically, we'll adjust those y values. So it'll either shift them up or down, whatever the value of c is. Okay, so some practice for you with these problems here. And that's the last thing I want you to do, is to try and do these questions for yourself. And then solutions will be posted on the Firefly page. I want you to check those solutions and see how you went with this particular part of it. And we'll review this in our next lesson.